I'm going to do an application problem that uses a quadratic equation. A security fence encloses a rectangular area on one side of a park in a city. 3 sides of fencing are used, since the fourth side of the area is formed by a shed. The enclosed area measures 192 square feet. Exactly 40 feet of fencing is used to fence in the 3 sides of this rectangle. What are the possible dimensions? So I like to draw a picture. So we've got this shed. And then we have a rectangular fenced-in area, which has a length and maybe a couple of widths, because we aren't using the shed. So first of all, the enclosed area, the area is 192 square feet. To find an area, we go length times width. And we know that is 192 square feet. I'm going to solve it for the length, so I'm going to divide both sides by the width. So we get the length equals 192 divided by W. Now we also know that exactly 40 feet of fencing is used to fence in the 3 sides. So if we're going to add up all the sides that we're using, we have a W plus an L plus a W, and that has to equal 40 feet. So we're going to take what we originally found up here, that L equals 192 plus over W, and we're going to substitute it in for the L here. I'm also going to make that length plus 2W equals 40. So, and that's equals, so I'm going to plug or substitute what we found before in for the L. So we get 192 divided by W plus 2W equals 40. We really need to get rid of that fraction, so I'm going to multiply everything here by the LCD, which is W. So I'm going to multiply the first term by W, the second term by W, and even the 40 by W. So in the first term, the W's cancel and give me 192 plus, and this is 2W squared, equals 40W. Now we have a quadratic because we have the W squared. So to solve it, we have to get everything to one side and set it equal to 0. So I'm going to subtract the 40W to the left side. And I'm going to put the quadratic in order. So I'm going to start with the 2W squared. And I can't combine it with the minus 40W, so I'm just going to write it. And then add the 192. And that's the left side. And on the right side, 40W minus 40W is just 0. So once we have that, we can actually use the quadratic formula to solve it for W. So we have W equals, and it's a negative B. Well, we have a negative, and then B is negative 40 plus or minus the square root of a negative 40 squared minus 4 times A, which is 2, times C, which is 192. All over 2 times A, which is 2. Now let's simplify. We're going to do our exponent first. So negative 40 squared gives us 1600. So we have, we have a negative of a negative 40, which is positive 40, plus or minus, and negative 40 squared is negative 40 times negative 40 is 1600. And then we have minus 4 times 2 times 192 is 1536. And that's all over 2 times 2, which is 4. Okay, let's do the subtraction in the square root. So that gives me 40 plus or minus the square root of 1600 minus 1536 is 64. Now let's do the square root. So we get 40 plus or minus, and the square root of 64 is just 8 over 4, which gives us actually two options here. So we have W equals 40 plus 8 over 4, or we have W equals 40 minus 8 over 4. Let's solve the top one. So 40 plus 8 is 48 over 4. So that is, when we divide it, that gives us 12. So we have 12 feet as a width. Or we have 40 minus 8 is 32 over 4. So we can also have an 8-foot width. Now to find the length, let's go back up here. We know that length times width equals 192. So to figure out, when we know that the width is 12, we go 192 divided by that will give us the length. So 192 divided by 12 is 16. So one set of dimensions would be a width of 12 and a length of 16 feet. Now the other one, if the width is 8 feet, then we have 192 divided by 8, which is 24 feet. So the other set of dimensions is 8 feet by 24 feet.